our actual topic of capacitors. We'll start from here. So what is a capacitor? Any body which stores charge, or we can say which stores electric energy, clear ma, in the form of electrostatic field, okay ma, is called a capacitor. Okay, so what does a capacitor do basically? So it is helpful for storing some amount of charge, clear ma, and when that charge is stored, electric field will be developed, no? So existence of electric field is an example of existence of energy. Okay, so energy is stored in the form of electrostatic field. So this is a capacitor, and whenever it is required, clear ma, capacitor releases this charge or energy. Okay ma, so whenever it is required, definitely it will release some energy. Okay ma, so this is what is called as a capacitor. Okay, now the question is, how much charge we can give to a conductor? Clear ma? For example, if this is a conductor, clear? So let us consider there are many charges which are present at infinity. Okay ma? So at infinity there are many charges, infinite amount of charges are present, and separation between all these charges is also infinite. Let us assume like this. Clear ma? Now I will bring one charge of this one and deposit here. Okay, so one charge which is present at infinity, I am taking from infinity and depositing on the surface of this body. Clear now ma? So if I deposit one charge, then what is the change which is going to happen ma? Previously, before adding the charge, and now after adding the charge, what is the change, what is the difference that will happen? Can you see? Difference is that potential of this conductor increases. No? Potential of this conductor increases. Clear ma? For example, if it is a sphere, then what is the formula for potential of a conductor? V is equals to KQ divided by R. This is the formula, no? Potential of a conductor is equals to V is equals to KQ divided by R. Are you able to understand? So therefore, can I say that potential is directly proportional to charge ma? Potential is directly proportional to charge, no? So what is meant by potential is directly proportional to charge? If I add one charge, potential increases. If I add another charge, potential further increases. If I add another charge, potential further increases. If I add one more charge, potential further increases. So potential of this conductor continuously increases as a charge is continuously deposited on this conductor. Clear ma? If a potential increases, what happens to electric field? If potential increases, what happens to electric field ma? Come on, what happens? If a charge on a conductor increases, what happens to electric field of that conductor? For example, if I take a sphere, what is the electric field of a charged sphere? Yes, E is equals to KQ divided by R square, no? E is equals to KQ divided by R square. So as the amount of charge which is deposited on this conductor or any body increases, then electric field of that body also increases. Clear now? So now my question is, so how much amount of a charge I can deposit on this conductor? That is the question. Clear ma? So on this conductor, how much amount of charge I can deposit? Clear ma? So capacitor, that is called a capacitor now. So which stores a charge is called a capacitor. So how much charge I can store on this capacitor? That is my question. How much charge I can store? Can I store infinite amount of charge, or can I store only certain amount of charge? So is capacitance of any conductor, is it infinite, or capacitance of a conductor, is it limited? That is my question. Can you say ma? See ma. So limited. Why it is limited? Why it is limited? So can't I store any amount of charge on this one? Can't I store any amount of charge? So I cannot store infinite amount of charge on this one. The reason is that, Sima, one reason is this: as I go on depositing charges on this one, so potential of this one continuously increases, no? Potential of this conductor continuously increases. And what is the basic meaning of potential? Potential is nothing but work done per unit test charge, no? Ma? Potential is nothing but the amount of work done to take a unit test charge from infinity to a particular point is called as potential. So if a potential continuously increases, work done also continuously increases. Clear, Nama? So if a huge amount of potential is developed here, then to bring another positive charge, I have to do a huge amount of work. So huge amount of work I have to do that practically it may not be possible to do so much amount of work. So this is one reason. Are you able to understand, ma? If potential increases, so the electrostatic force of repulsion between these charges and these charges, they continuously increase. So therefore I have to do very huge amount of work. So huge amount of work I have to do such that it is not possible. So this is one reason. Another reason is that, clear ma? This charge, it is present in atmosphere, no? This conductor is present in atmosphere. And atmosphere has a dielectric breakdown of E is equals to 3 into 10 power 6 volts per meter or newtons per coulomb. Are you able to understand, ma? So what is this value called as? This is called as dielectric breakdown of air. Dielectric breakdown of air. What is meant by dielectric breakdown of air, ma? Dielectric means it is an insulator. Air is an insulator, no? Air is an insulator. Now to air, if I can supply this much amount of this much amount of electric field, then air also behaves like a conductor. Air also will behave like a conductor at what electric field? At an electric field of 3 into 10 power 6 volts per meter. Clear, Nama? So as I continuously deposit charges onto this conductor, so electric field of the conductor continuously increases. So if electric field reaches to a value of 3 into 10 power 6 volts per meter, then air around this conductor also starts conducting. Clear, Nama? So after depositing one more charge, now let us consider the electric field around this conductor is 3 into 10 power 6 volts per meter. Now what will happen? Now air around this conductor, it will break down. It will also start conduction. Clear, number? So you add one charge will be leaked into the atmosphere. You add two charges will be leaked into the atmosphere. You add three charges will be leaked into the atmosphere. Are you able to understand, ma? So you can add any number of charges, but they will not be present on the conductor. They will be leaked into the atmosphere because now air is also behaving like a conductor. Are you able to understand, ma? So therefore by this we can say that a conductor cannot be charged infinitely. So we can charge a conductor only up to a certain limit. So what is the minimum limit, ma? Minimum limit is until the conductor's electric field will become 3 into 10 power 6 volts per meter. That is the meaning of this one. Clear, ma? Now you write this information in your own words. Clear? So what you can write, if I add one charge such that electric field around this conductor will become 3 into 10 power 6 volts per meter, then dielectric breakdown of air happens. So as you go on adding the charges will be leaked into the atmosphere, and electric field of this conductor remains to be 3 into 10 power 6 volts per meter. So write this one in your own terms.